Today we're working on 1.3. This is going to be a two-part section, so this is part A of 1.3. And this is variables on both sides. So to start off, I've got a quick review. You should have all of this written down already, so you shouldn't have to write it down again, but I just wanted to go over it. So the first thing that you should always do when you're trying to get x equals something is separate the equation at the equal sign. Then you want to combine the like terms on both sides of your equation, so on your left side and your right side. Simplify it down as far down as we'll go. The third thing that you should do is ask yourself what's happening with addition, subtraction, do the opposite on both sides, and then what's happening with multiplication, division, do the opposite on both sides. For these ones, since we are dealing with variables on both sides, we're going to combine our variables first. And so we're asking ourselves what's happening with this addition or subtraction with our variables first. So let's go over what I mean by that. So if we look at this first problem here, we've got 15 minus 2x equals negative 7x. So I'm drawing my line. This left side and this right side are both simplified down as far as they can go. But I do see that I have a variable on the left and a variable on the right. So that means that I have to combine those two. I'm going to ask myself what's happening with addition or subtraction. So let's say that I wanted to move this 2x over to the other side. I'm looking at a negative 2x over here. And so to get rid of that on the left side, I actually have to add it to both sides of my equation. So I'm doing plus 2x on both sides. That gets rid of that and leaves us with 15. Now I'm looking at negative 7 plus 2. Negative 7 plus 2 gives me a negative 5. And we keep our variable x. Now we have it down to a one-step equation. And so I see negative 5 is being multiplied by my x. What's the opposite of multiplication? It's division. So we're dividing by whatever the number out front is, the coefficient. So that's a negative 5 out front. And then that gets rid of that, because negative 5 divided by negative 5 gives me a 1. X times 1 is x. Now looking at that left side, I've got 15 divided by negative 5. I know a positive and a negative makes a negative when dealing with addition or dealing with multiplication or division. So I know that my answer is going to be negative. Now I'm going to look at the numbers. 15 divided by 5 gives me a 3. So I've got x equals negative 3. Let's go back and check my answer. So our original equation was negative or positive 15, sorry about that, is positive 15 minus 2x equals negative 7x. I'm going to substitute in this negative 3 for every single x that I see. So I've got 15 minus 2 times negative 3 equals negative 7 times negative 3. Let's start off with our multiplication. So I've got a 2 times a negative 3. So 2 times negative 3 is going to give me a negative 6. So I'm going to write negative 6 in that place. And then negative 7 times negative 3. Well, negative times a negative is a positive, so I'm going to have a positive answer. 7 times 3 is 21. So I've got 21 on that right side. Now I'm going to do 15 minus negative 6. I'm going to KCO that. By KCO, I mean keep, change, opposite. So we're keeping our first number, changing our subtraction, so it's addition, and then doing the opposite of our second number. So I've got a negative 6 now. The opposite of a negative 6 is a positive 6. So I'm actually looking at 15 plus 6, which gives me a 21. And 21 does equal 21. So I know that that checks out. 21 does equal 21. So I know that my answer is correct. If I ever ask you if a solution works, so if I said, I think that x equals negative 3, am I correct or not? And you will have a problem like this on your homework. All you're going to do is substitute in, just like how I did right here when we checked our solution. So I give you a solution. All you have to do is substitute, plug it into your x's, and simplify to see if it works out at the end. And then you're going to tell me, yes, it does work. And you know it does work if you have a true statement. So 21 does equal 21. And you know it won't work if you get a false statement. So if you got 3 equals 27. 3 does not equal 27, so that solution does not work. Let's move on to the second problem now. What I want you to do is to pause your screen and try this problem out. Look at what I have written over here. Try the problem. I'm going to go through every step, and you can check your answer with me after you're done, and I'll explain it once you're done as well. So go ahead and pause your screen now. And here's my answer. So I have the problem solved over here, and then I checked my solution over there. So the first thing I noticed after drawing my line is that I had an x on the left and an x on the right. And so I know that I need to combine those. I decided to move this one over here because I wanted a positive 2x. That's the only reason I chose this x over that x. You could honestly choose either x, and you're still going to get that same correct answer. So I added x to both sides, which eliminated that because they're opposites, and I was left with an 8. And then I added those two x's together. Remember, when you're working with those x's, there's always going to be a 1 in front of your variable, so you're looking at 1 plus 1. So if there's no number, you always have that 1. And so that's going to give me a 2x because there's two x's being added together. Next thing I needed to do was get rid of all of those numbers on the x side. So my x is right here, so I'm circling that variable because my goal is to get down to just a single x. So I added my 10, and I got 18 equals 2x. Now I see multiplication, so I'm doing division. Divide by 2 on both sides, and you get x equals 9. And then that's me checking it over there. So I know that it is correct because I got -1 equals -1, and that is a true statement. You try these two problems. I'm not going to explain these answers, so if you do have questions over it, make sure you email me, but check your answers in a second. So pause your screen now and try those two problems. And here are my two answers. So for the first equation, I got x equals -4, and I checked that solution there. And then for the second one, I got 7/2 or 3.5. So I would accept either of those answers. They're both totally fine. So if you want to keep it as 7/2 as like that improper fraction there, I would accept that answer. If you wanted to convert it into a decimal, I would also select or accept that answer. And then that's me checking that solution there. I could also give you some distribution problems. So make sure that you're distributing before you get this done or before you move the variables. So I see this distribution there. So when I'm looking at my equation, I know that I have to do that distribution first. So I'm going to take that 6 and multiply it by my 4 and by my y. 6 times 4 gives me a 24. And then I've got a subtraction sign. And then 6 times y gives me a 6y equals 2y. Now, since I've got that distribution done, I can combine my variables across that line. And so typically, I am going to be moving this one over here because there's nothing left. And so I don't want to be left with a 0 there. So I'm going to move this one over to that other side. It would work if you chose the other one. It doesn't really matter. As long as you follow the math steps correctly, you should get the same answer. And so that's going to leave me with a 24 on the left because I got rid of that minus 6y. And then I've got 2y plus 6y. Well, 2 plus 6 gives me an 8. So at the end, I've got 8y. My goal is to get y by itself. I should have y equals some number. And so I see multiplication happening there. I've got to do the opposite, which is going to be division. And so I'm dividing by 8 on both sides. 24 divided by 8 gives me a 3. So I know that y equals 3. I'm going to go in and check my solution. So I've got 6 times the quantity, 4 minus 3. I got that 3 instead of the y from right here. It's telling me exactly what y equals, so I'm using that 3. Equals 2 times y, or 2 times 3. Now I'm going to go through and solve it using my order of operations. So first comes parentheses, so I've got 4 minus 3. So I've got 6 times 4 minus 3 is 1, equals 2 times 3. Now I'm going to do my multiplication. 6 times 1 is 6. 2 times 3 is 6. Now I've got 6 equals 6. That is a true statement, so I know my solution is correct. Again, pause the screen. I'm going to be doing the same thing that I did before with writing out the answer, just like how I did for this first problem, and I'll go through and explain it. So pause your screen now and try that problem out. And here's my answer. So the first thing that I realized was I needed to distribute on both sides. So I did my distribution on this line here. While I was looking at that, I had -2 minus -10. That looks really confusing, so I just went ahead and KCO'd that. So I could have -2 plus 10, which is a lot easier to look at. Next, I wanted to combine my variables, so I decided to move this 3x over to the other side. So to get rid of a -3x, I'm going to have to add 3x. And so I did that to both sides of my equation, which got rid of that on the right side. But on the left side, I was left with a positive 1x. If I take x times 1, I'm going to be left with x. And so I know that I'm done with that. But I still have that plus 10. So I have to subtract 10 from both sides to get rid of that and be left with just an x. And then 12 minus 10 gives me a 2. And then I check my solution over here. 6 does equal 6, so I know that I did that correctly. Go ahead and try these two problems. Obviously, they both have distribution, just like the previous two problems that we worked together. And then I will give you your answer when you're done. So pause your screen now. And here are my answers. So for the first equation, you should have gotten x equals 5. And then I checked it down here. And for the second equation, you should have gotten y equals 44. And I checked it over there. And here's your homework. So you're going to be on page 23 in your textbook, and you're doing these problems here. So you're doing numbers 1 and then 6 through 15. If you got any questions, please send me an email.